Okay, so are we ready, peoples? I'm just gonna go over what I did already. Since it's recording, let me get my name out of that. All right, so number one, you just need to be concerned with the point P moving around the circle. And when we are talking about one complete circle, it's 2 pi. Finding the exact values in number 2, we're going from pi to 3 pi over 2. So we're only talking about the region. So no matter what it says on your actual test, you know, if it's going from 0 to pi over 2 or 0 to pi, whatever it says, just follow that. And then you just need to use your unit circle to, or you could use the calculator, TIN Spires. All right, and number 3, all we need to do is kind of the same thing. You're just finding the exact values. So your answer should be in from the coordinates on the unit circle. So 1, 0, 0, 1, -1, 0, 0, -1, and then tangent, of course, is a combination of sine and cosine. Just converting from radian measure to degrees, you know what to do. You either are multiplying. So if you're going from radian to degrees, you need to multiply by 180 over pi. But if you're going from degrees to radians, you're multiplying by pi over 180. Finding the exact length of the arc intercepted by the given central angle in the figure to the right. We just needed to multiply the two numbers together. So if you think about it like that, it's just very simple. So you don't have this written down already? I'm just kind of making, I'm making a video. Oh, you have it? You have it? Okay. I'm just making sure. I'm just like going over it because I'm making a video. And then finding the exact function value, similar. You just need to find the values. And when we're talking about tangent, we're talking about sine and cosine, because remember that tangent is also y over x, which is also sine over cosine, which is also one of the first things you do. So if anybody in here is going to take calculus, this is the first thing that you do in calculus. You are going to find the slope of the tangent line. That is the very first thing. Well, you're going to do limits, right, in pre-calculus or calculus, but I wish that my professor would have told me that this was going to be something that was needed, because I didn't understand that until I was way done with Calc 1. Once it was done and over with, you know. Anyway, so for number 7, I already went over that. You just multiply by pi over 180 to get to radians. The same thing with number 8, very similar to number 6. You're just finding the values on that unit circle. And then for this one, we are just using the x and y values to find sine, cosine, tangent, secant, cosecant, and cotangent. Be very careful because I always make the mistake that these two are lined up because sine is first. So I feel like since sine is first, that cosecant should be first listed, because I know that they're just a flip. But they always do it backwards. I don't know why. I mean, if we, even alphabetically, that doesn't, I would be fine if you do cosine first, but we always do sine first. I don't know. Because cosine is x. I don't, you know, that's just me, my little pet peeve about order. And then for number 10, this one just utilized the formula for linear speed, which is r times omega. So that little w is called omega. You just need to multiply the meters times the revolution one time around the the radius times the going around the circle one time is 2 pi, right? So you just need to multiply the meters by that, the radius by that. And then we need to take what we get from that here and then multiply it by the 42 times per minute. And that's how we end up with that answer. Converting radian measured to degrees. So we're going to take the radians here and multiply it by 180 over pi. And then we get 900 over pi, which is approximately 286.47. And then we just take the 0.479, multiply it by 60 to get the minutes here, which is about 29. And remember, this is a video, so I will post it. And then number 12, the tires of a bicycle have a radius. Now, as soon as someone says radius, you should be thinking circle, right? Center of the circle out to the edge is the radius, and are turning at a rate of 220 revolutions per minute. How fast is the bicycle traveling? So we're looking for speed. So we have omega, which is going to be, what was that? The revolutions, the rate times the going around the circle one time. And we get 440 pi. And then we take that 440 and just multiply it by the radius. So, okay. And so we needed to multiply. I must have missed writing that down. So we need to, because this is in minutes right here. Oops, that's in minutes. We needed to multiply by 60 to get hours. That is why we did it. Make sure I got everything else. So we got 369. Okay. Oh, that's okay. So that's how we got this number here. And then we needed to convert to miles because we had inches. So we needed to convert that. And then, okay. So you got 35 pi. Oops. Let me write it down here. 35 pi over 6. Okay, that was a little thank you. Awesome. Okay, so because they gave us per minute, we needed to change that minute into an hour, right? So that's why we multiply by 60. And then we get the number, the big 369, 600 pi. And then we need to consider that it's per hour. So now we have it in hours. And then we multiply by 1 foot over 12 inches because that is in inches. And we need to convert it to miles per hour. Okay, so we already had it in hour. Then we need to convert that into miles. Okay, so that's where that part came from. And then I don't even remember. What was the final? How much time? Oh, it's 8:59. Oops. I'm going to have to stop the recording, y'all.